Hi guys, welcome to this set of videos. And what we're going to be doing here in these lessons is the videos are going to follow along with all of the notes out of Chapter 5. Now, Chapter 5 is going to deal primarily with polynomials. And what you're going to find is that it's going to look a lot like the other chapters we've already looked at. What we're going to do is we're going to deal with polynomials, but we're going to look at graphing polynomials, we're going to look at factoring polynomials, we're going to look at solving polynomials, all that stuff that we've done with quadratics in previous chapters, with linear functions in previous chapters where we're graphing, factoring, solving, all that same stuff. Just now in Chapter 5 we're going to do it with what's known as a polynomial. Now, polynomials are just a real simple definition. A polynomial is going to be an algebraic expression or equation, all right? Algebraic expression or equation that has a finite number of terms. That means it's not infinite. It has to end somewhere, all right? It's got to stop. It can't go on forever. And you're going to have terms raised to powers, right? Generally a number of different powers, and each term, you could have some terms that are to the same power, but in most cases we'll write the terms in descending order of power. So the largest power starts the polynomial and sort of descend through the power as you go through the polynomial. Again, those are really the big things though. The polynomial must be finite. It has to end. It cannot be infinite. And every term is going to be raised to some power. The variables will be raised to powers, which is why they're not linear, right? Of course, if it was linear, the variable would be to the first power, and quadratics being to the second power. So we're going to primarily be dealing with powers greater than 2 here in this chapter. But before we get into any of that, a couple of targets or learning objectives, the things you should be able to do by the time we get to the end of this set of notes or these videos. You're going to need to be able to multiply. Oh, sorry, hold up. I apologize. That is not my highlighter. 1 second. There we go. You're going to need to be able to multiply, divide, and simplify monomial expressions involving powers. Since we're going to be dealing with a lot of exponents, a lot of powers in this chapter, we're going to actually take this first section to review all of the properties of exponents that you learned in Algebra 1, and then take a look at a number of example problems where we have to use them. And then the last thing we'll do at the end of this section of notes is add, subtract, and multiply polynomials. We'll actually get to dealing with operations of polynomials. So let's jump right into it. Here we go. This is a complete list of all of the properties of exponents that you guys would have seen in Algebra 1. Now, I will remind you of just a couple of them. You'll become real familiar with them as we run through the example problems. But again, just to sort of refresh your memory, anytime these have to be like bases, meaning the numbers or the variables that are raised to the power are the same, right? So it would have to be an x squared and an x cubed, right? Or a y squared and a y cubed, right? I couldn't have an x squared and a y cubed. The bases aren't the same. X and y is not the same. So same base, as long as you have the same base, if those bases are multiplied, add the exponents. If those bases are divided, right, if you have an x squared in the top and an x cubed in the bottom, as long as the bases are the same, division means you subtract the exponents. Those are the ones you guys should know right away. One that may be a little bit more obscure or you might not remember is actually this one right here. We're going to use it a lot. You'll see it shows up quite a bit, and we'll get practice with it when we do the example problems, but it's just simply this one. You can move a variable from the numerator to the denominator by simply changing the sign of the exponent. I'll show you in a second. Or you could move a variable from the denominator into the numerator, again, by simply changing the sign of the exponent. Let me show you real quick. If I had an x to the negative second power, right? X to the negative second power. Well, in order to make that exponent positive, I just simply take that x to the negative second power and move it to the bottom. Change the sign of the power and I make it 1 over an x to the positive 2. Same thing. Same. This property of negative exponents allows you to take a negative exponent, You move it to the denominator to make it positive. If I had this, 1 over a y to the negative third power. I have 1 over y to the negative third. Well, this property says you could go the other direction. If I want this exponent to be positive, I simply bring the y cubed to the numerator and change the sign of the power. So I now have a y to the positive third power, this negative exponent property. Now, one quick thing to watch out for, and it is this. If you have a 4x to the negative second power, 4x to the negative second power. You need to be very, very careful here. You are not taking the entire thing to the denominator. I get lots of Algebra 2 kids make this mistake. Please don't let this be you. If you have 4x to the negative second power, this is not. It is not equal to 1 over 4 to the x squared power. Yes, absolutely, the x to the negative second. You take that to the bottom and make it an x to the positive second power. Absolutely, that's the way the property works. But this 4 is not raised to a negative exponent. The 4 is raised to a positive 1 exponent, which you actually didn't do anything to. You only changed the sign on the variable. So that 4 cannot go to the bottom. You need to leave it in the top. Please be very, very careful. It would be 4 over x to the positive second power. Now, what you could do here, if you wanted to make it equivalent, was take that 4 and raise it to the negative 1 power. That is absolutely an equivalent statement. So I could say is equal to 1 over 4 to the negative first power, x to the second power, right? That is absolutely okay because you've changed the sign of both of the powers and taken them both to the bottom. The only problem with this is we don't like negative exponents. That's actually the whole purpose of this property. When simplifying, you'll see here in a second, negative exponents are no bueno. We don't like them. And so you'll never have a final answer. Your final solution will never have a negative exponent in it. So you'd actually just bring that 4 right back to the top anyway and leave it as a 4 to the positive 1. So anyway, hopefully that helps you guys out with that negative exponent property. That is definitely the trickiest one. And again, you should have seen that in Algebra 1, but if you didn't, there's just a quick explanation of how it works. And please be very, very careful. You're only going to take to the denominator or to the numerator the term that you have changed the power of the exponent for. Okay, a couple other ones here. The power rule, if you have a variable raised to a power, and then that's all raised to a power, you guys know that you simply multiply those exponents. Anytime you have something in parentheses and that quantity is raised to a power, everybody inside the parentheses gets raised to that power. Again, really simple stuff. Same thing if you have division. You have a quantity where you have, I don't know, say you have an x divided by a y. Well, if that quantity is raised to a power, you can do x to that power, y to that power, right? Everybody gets raised to that power. We'll see those again, but you should be familiar with them. And then just this one last one, and I'll explain it to you here in a minute as we're doing some example problems, how it works out this way, because I know it seems counterintuitive. I promise you, it makes perfect sense. It's not some kung fu ninja math trick. It's awesome. But anything raised to the 0 power is equal to 1. And I know you might think, well, wait a second, it's raised to the 0 power. Why is it not equal to 0? I'll show you why here in just a second. So anyway, that takes care of those guys. What I want to talk about here next as we jump into example problems is this. To simplify an expression containing powers just simply means that we're going to rewrite the expression without parentheses or negative exponents. In fact, let me give you a comprehensive list of what you need to do in order to simplify these expressions with exponents. Here's the things you're looking to do. First, you need to make sure that there are no powers of powers. Right? You can't have anything raised to a power and that quantity raised to a power. If you have that, then you're not fully simplified. You'll need to go a little further. Each base can only appear one time. You can't have an x cubed and an x squared in your solution. You'd have to combine those, right? Combine like bases. Fractions are, of course, in simplest form. You guys know that. And there can't be any negative exponents in your final answer, which was the whole point of me going over that negative exponent property with you just a second ago. So let's go ahead and try a couple of these here real quick. Again, once you get the hang of these, which you guys should pick these up real quick, go ahead, try them on your own, and then come on back, check to make sure that you get what I get. The first one I've got for you here is 2a to the negative second, that quantity, multiplied by the quantity 3a to the third, times b to the second, multiplied by the quantity c to the negative second. Now, there's more than one way to do these. There's several different routes you could go, and they're all going to lead you to the same place, all right? So I don't want you to think that you have to do it my way or you won't get the right answer. It's just simply not that way. You could go a couple of different routes. For example, I have an a to the negative second and an a to the third. Well, anytime you have like bases, you simply add the exponents. Yes, absolutely, you could do that. Or you could take a look at this and go, oh, I have negative exponents. I know I need to get rid of those. And you could simply make your first step getting rid of negative exponents. Absolutely, right? There's many different kind of paths that you can take. They're all going to lead you to the same answer as long as you do your algebra right. So again, please don't think that you have to do it in the particular order I do it or you're not going to get the right answer. That's just not true. I do, however, like to get rid of my negative exponents first. It just makes the most sense to me, so that's what we're going to do. I'm going to go ahead and take that a to the negative second. I'll drop it to the bottom and get this 2 over a squared. So I now have 2 over a squared. I still have this quantity, 3a cubed b squared. And then this guy over here, I'll show you why I left it like that in just a second. The c to the negative second, go ahead and move that c to the negative second to the bottom. So that it is 1 over c squared. Oh, and awesome, let me make this quick note. Why did I not take the 2 to the denominator as well? Well, because I didn't change the sign on the power of the 2, right? This 2 is to the first power. If I had made that 2 to the negative first, then yes, that 2 would have gone to the bottom, but then I'd have a negative exponent, and that completely defeats the purpose of what we're trying to do here. So again, I have only changed the sign on the power of the a. So that's why it's the a that gets moved to the bottom, and that 2 stays in the top. I didn't change the power that 2 is raised to. I only changed the sign of the power of the a. So that's the only thing that goes to the bottom. Now, again, real quick here, I just want you to see this. You should not. You should be in a place where you don't need to do this, but I just want to show it to you anyway. Again, remember, we're multiplying all these guys together, and I now have a bunch of fractions. You can just simply put that guy over 1, right? Again, you shouldn't need to do this. You should be able to see this without having to put that middle quantity over 1, but just to help you guys sort of here on our first example problem, recognize I've got a fraction times a fraction times a fraction, which of course means we multiply the numerators, multiply the denominators, and then simplify from there. So here we go. Multiply the numerators. 2 times 3, 6. I have an a cubed. I don't have any other a's, so it'll just be an a cubed. I have a b squared. I don't have any other b's, so it'll just be a b squared. And of course, I can multiply anything by 1. It doesn't change one bit. That's all divided by, multiply all my denominators. A squared, a 1, and a c squared means I have an a squared and a c squared. Okay, awesome. So here's what I've done. I've now gotten rid of all my negative exponents, and I have multiplied my quantities together. Fantastic. Okay, now what I need to do in order to simplify is make sure that all my fractions are in simplest form. They're completely reduced, and I don't have any like bases, which actually is my problem right now. I have an a cubed in the top and an a squared in the bottom. So we go back to our properties of exponents, and we know the one about fractions, right? Anytime you have like bases, top and bottom, you subtract the exponents. Well, that means that I have an a cubed divided by an a squared, which would be an a to the 3 minus 2, which leaves with an a to the positive 1. You could also simply think of it like this. You have 3 a's in the top, you have 2 a's in the bottom. Well, 2 of the a's in the bottom cancel with 2 of the a's in the top, leaving you with just 1 a in the top. That is a great way to think about it, and if you can sort of picture that in your head and cancel out those a's, you're good to go. You'll have no trouble with any of these problems. So anyway, here we go. My fractions are completely reduced. I don't have anything to cancel with the 6. I don't have any like bases. I have an a, a b, and a c. Those are all different variables. I don't have any negative exponents, and I don't have any powers of powers. Guys, that is your final answer. You have completely reduced this original expression. Great, let's try another one. All right, let's jump right into this one. Looks like what we're going to do here is just a whole bunch of canceling again, and I just want you, I'm actually going to show you this two ways. Two different ways of thinking about it. I don't care how you do it. I don't care how you think about it. Do whatever makes the most sense to you, okay? Because everybody kind of thinks differently when it comes to solving these problems and logically working their way through mathematics, and that's fine, right? Many different ways to do this. So here's the first way. What I would do is just write all of this stuff out. I have a q squared. Well, that's a q times a q. And then I have an r to the 4th, which would be an r times r times r times r. All right, that's my top. In the bottom, I have a q to the 7th. Well, that's going to be 7 q's. 1, 2, 3, 4, 5, 6, 7. 7 q's. And r to the 3rd, I need 3 more r's. R, R, R. All right, now, here's all you've got to do, right? We know that anytime you have a fraction, right, you can cancel like terms top and bottom. Q, Q. Cancel them out. Q, Q, cancel them out. I have an R and an R, so those will cancel. I have an R and an R, so those will cancel. I have an R and another R, so those will cancel. Now that I've canceled everything I've got top and bottom, we just simply write what's left. All that's left in the top is an R. All that's left in the bottom is 1, 2, 3, 4, 5 q's. So a q to the 5th power. Guys, that's going to be your final answer. You don't have any numbers, so you can't reduce any fractions. I don't have any powers of powers. I don't have any like bases. Like, we're good. That is completely simplified. Now, another way to think about this, and actually this is the way that I like better, we have, right, quotients. I have a q squared over a q to the 7th, that's division, and an r to the 4th divided by r to the 3rd. Properties of exponents says, when you have a like base, subtract the exponents. So what this is, q squared over q to the 7th times r to the 4th over r to the 3rd, this is simply a q. 2 minus 7 times r, 4 minus 3. Right? That's what the property says. Whenever you have division with like bases, you subtract the exponents. 2 minus 7. It's always top minus the bottom, the top exponent minus the bottom exponent. And r to the 4th divided by r to the 3rd would be r to the 4 minus 3. Well, again, go ahead and do that. Q to the 2 minus 7 would be q to the negative 5th. And r, 4 minus 3, would be r to the 1st times r. Well, to finish it off, again, you can't have negative exponents, so we're going to take that q to the negative 5th, drop it to the bottom, and that leaves you with an r over q to the fifth. Again, two different ways of doing the exact same problem. You get to the exact same answer. Again, if one of those fits your eye better,